Our sun, this big, bright, fiery ball in the sky, might seem like magic, but its power comes from something real: nuclear fusion. Deep inside the sun, tiny bits, even smaller than atoms, crash into each other and join together. This joining, called fusion, makes a huge amount of energy that lights up our solar system. Fusion has powered stars for billions of years. It's the universe's main energy source. Think about how powerful the sun is, then think about billions of suns, each one a fusion powerhouse scattered across space. This amazing energy source, usually found only inside stars, is now something humans are trying to create. Scientists worldwide are working to make and control fusion here on Earth. If they succeed, fusion could change everything, giving us clean, safe, and almost endless energy. Figuring out fusion is like trying to catch a star in a bottle. It's super tricky and pushes the limits of science. But imagine a future powered by the very heart of stars. That's why it's worth trying. Fusion is like a careful but powerful dance of atoms. Imagine the tiniest things, smaller than atoms, called deuterium and tritium. These are types of hydrogen, the simplest and most common element in the universe. When these tiny bits get incredibly hot, they move super fast, crashing into each other with huge force. If everything is perfect, they fuse together. This makes a new element, helium, and releases a lot of energy. Fusion makes millions of times more energy than burning fossil fuels. This is the big difference between fusion and fission, which is used in today's nuclear power plants. Fission splits atoms, fusion joins them. Fusion is much cleaner than fission and doesn't make long-lasting radioactive waste. This makes it a much better energy source for the environment. The ingredients for fusion, deuterium and tritium, are easily found in seawater, meaning we'll never run out. Making the same conditions as inside a star here on Earth is really hard. Fusion needs incredibly high temperatures, hundreds of millions of degrees Celsius. That's hotter than the sun's center. At these temperatures, atoms break down into a swirling soup of charged particles called plasma. Holding and controlling this superhot plasma is one of the biggest challenges. Imagine trying to hold the sun. That's how hard it is. Another big challenge is reaching ignition. Ignition is when the fusion reaction keeps itself going, making more energy than it uses. Reaching ignition is key to making fusion power work. Even though it's difficult, scientists are making progress. Years of research have taught us a lot about plasma and fusion. New materials and clever engineering are being developed to handle the extreme conditions needed for fusion. Section 4. Taming the plasma magnetic confinement. One way to do fusion on Earth is using magnetic confinement. This uses strong magnets to hold and control the superhot plasma. Imagine a giant magnetic bottle, keeping the plasma in place so it doesn't touch the reactor walls. The most common type of magnetic bottle is a tokamak. Tokamaks are donut-shaped with a central chamber where the plasma is heated and held. The world's biggest tokamak, ITAR, is being built in France, showing how countries are working together on fusion. Another promising idea is the stellarator. Stellarators have a more complicated, twisted shape than tokamaks, but they might be better at holding the plasma steady. Both tokamaks and stellarators need supercold magnets to make the strong magnetic fields for fusion. These magnets work at temperatures close to absolute zero, making these machines even more complex. Section 5. The power of light, inertial confinement. Magnetic confinement uses magnets, but inertial confinement uses powerful lasers. This method uses lasers to squeeze and heat a tiny pellet of fusion fuel. Imagine lots of lasers, each stronger than the sun, pointing at a target the size of a grain of pepper. The lasers blast a huge amount of energy in a split second, making the fuel pellet implode. This creates the high temperatures and pressures needed for fusion. The National Ignition Facility in the US is a top research center for this. In 2023, NIF made history achieving ignition in a lab for the first time. This showed that controlled fusion is possible and was a big win for fusion energy research.